Morning everyone. Today we'll be going through the 2022 AMAth paper 2. I had a look at this paper and it seems to be easier than paper 1, so it balances things out because paper 1 is a little bit tricky. In 2010 we have 2400 birds of a particular species. In 2013 it drops to 2050. So if n is 2400 e power negative kt, t is the time in years after 2010. Estimate number of birds in the year 2017. So first we need to find the value of k, right? So we have 2400 e power. Now if I put in t equals to 3, I'll get negative 3k. And this is 3 years after 2010, right? 2013. So we know that this is 2050. And from here we can solve for k. So if I take the natural logarithm on both sides, I'll get negative 1 over 3 ln 2050 divided by 2400. Okay? Where's my calculator? And you'll get 0.052543 for SF. Always use 2 extra SFs in calculations. Okay, and then how many birds are there in the year 2017? You just put t equals to 7. So you have in 2017 n equals to 2400 e power negative 7k. And you'll get to 3SF 1660. Okay. The species is labeled under threat when the number of birds falls below 1200. So which year might they first label under threat? Okay. So for this part, we let 2400 e to the power of negative kt equals to 1200. So I get t equals to minus 1 over k ln 1200 divided by 2400, which of course is just ln 2 divided by k. Which is 13.2 in 3SF. So it is 13 years after 2010, so the year will be 2023. Okay. So some people were arguing whether it should be 2023 or 2024. I think it's 2023 because like 13.2 is in the middle of 2023. So you can declare a species under threat even in the middle of the year, right? Yeah. So that would be the way I take it. It is given that we have this function which is cubic polynomial. We have a factor of x plus 2 and leave a remainder of 30 when divided by x minus 3. Okay, so this is a very standard question for the first part. If I have a factor of x plus 2, that means that if I put f minus 2 here, I will get minus 8 plus 4a plus 6 plus b, which is 4a plus b minus 2 equals to 0 because it's a factor. And if it gets a remainder of 30, when I divide by x minus 3, I can put in f of 3. I get 27 plus 9a minus 9 plus b, which is 9a minus b plus 18, and this is 30, right? And then I can proceed to solve these two simultaneous equations. I'll have yeah, so 4a plus b equals to 2 and 9a minus b equals to 12, right? Oh sorry, plus. Okay, so if I solve these two, clearly a is 2 and b is negative 6. So yeah, those being your values of a and b. Factorize f of x completely into three linear factors. This is x cubed plus 2x minus 3x, 2x squared minus 3x minus 6. If I factor this, I'll get x plus 2, and I'll get something on the form x squared plus ax, and then to compare the constant terms, 2 and minus 3, so you will get, yeah, so that you get the negative 6. Oh, I should probably not use a, because we already have a, right? Let's call this p. We can compare coefficients of x, or x squared also can. You'll get 2p minus 3 equals to negative 3, which implies that p itself is just 0, right? Which is pretty interesting. And therefore you get f of x equals to x plus 2, x squared minus 3. And it says that you want to factor it into three linear factors using surds where necessary. So if I solve x squared minus 3 equals to 0, you get plus or minus root 3. So in fact, you can do x minus root 3 as well as x plus root 3. Yeah, shouldn't be too hard even though this is a bit different. Question 3. Okay, my students told me they couldn't do the trigo proof. Let's have a look. Prove the following identity. Tangent 2 theta, 2 cosine theta minus secant theta is 2 sine theta. Okay, so of course we start from the more complicated side, the left hand side, right? Okay, so what I usually want to do is tangent 2 theta, it seems that we should expand it, right? So we know tangent 2 theta is the same as 2 tangent theta 1 minus tangent square theta, and I can actually expand the numerator and put in the 2 cosine theta minus secant theta, right? Okay, I know tangent is a sine over cosine, and I have some secant here that I may want to get rid of. So what if I multiply the top and bottom by cosine square? I'll get 2 sine theta cosine theta. So let me just make this clear. Multiply by cosine square theta on the top and bottom. 2 sine theta cosine theta, 2 cosine theta minus secant theta, and then divide this by cosine square theta minus sine square theta. Okay, so I know the bottom is cosine 2 theta, but we don't simplify that yet. Okay, so if I expand the top, let me actually take out the 2 sine theta. Let me actually keep the sine theta outside, and I'll put the, 2 sine theta actually. Let's put the 2 sine theta outside and multiply in the cosine theta. I'll get 2 cosine square theta minus 1. And I know that cosine square theta minus sine square theta is cosine 2 theta, which is also 2 cosine square theta minus 1. So the top and bottom cancel, and you're just left with 2 sine theta, which is the right hand side. Yeah. So that's pretty cool. Solve the following equation. Tangent 2 theta times, okay, so basically the same thing. Solve it equals to half secant theta. For this part, you're basically solving 2 sine theta equals to half secant theta. And if you multiply both sides by cosine theta, you get 2 sine theta cosine theta is half. And which is just sine 2 theta equals to half, right? And we know what the basic angle for this is. Alpha equals to 30 degrees. Is in degrees, right? Yeah. So because it's positive, ASTC, we get theta equals to alpha over 2, or 180 degrees minus alpha over 2, 360 degrees plus alpha over 2, or 540 degrees minus alpha over 2. 15 degrees, 75 degrees, 195 degrees and 245 degrees. No, 255 degrees. Yeah, so these will be your possible answers for this part. Question 4. We have a closed foot container designed in the shape of the cuboid. Rectangle is x by 3x, the height of the container is h. Volume of the container is 2000 cubic centimeter. Show that the total surface area of the 6 spaces is this. Okay, so we want to get this just in terms of x, so it may be helpful to get h in terms of x, right? So we know that 3x times x times h equals 2000. So we can solve for h in terms of x, which is just 2000 divided by 3x squared. So the total surface area, so we need 3x times x plus x times h, which is 2000 over 3x squared, plus 3x times the same thing. And everything here we multiply by 2 because there are each pair faces. The faces all come in pairs, right? So if I simplify, 3x squared plus 2000 over 3x plus 2000 over x. Sorry. Okay. If I factor out the 2000, I get 1/3 plus 1, which is 4/3. So you get 8000 over 3x. So you get 3x squared plus 8000 over 3x, which is 6x squared plus 16,000 over 3x. Yeah. Given that x can vary, find the value of x for which the total surface area is stationary. Okay, so let's say I call this a, so that I get dA dx you'll get 12x minus 16,000 divided by 3x squared, right? So we're going to solve for dA dx being 0. Let dA dx equals to 0. You'll get, if I multiply both sides by 3x squared, you'll get 36x cubed minus 16,000. Which can be simplified if I divide by 12. Oh wait, no, 16,000, sorry. Which can be simplified to x cubed equals to 4,000 divided by 9. And then you can find x from here. And the value of x you're going to get is 7.63 3SF. Okay? Determine whether this value of x gives a maximum or minimum value. For this, we can consider d2a dx squared, which is 12 minus, plus. Okay, so you will get a minus 2 power, so you bring it down, it becomes a minus 3. So you will get 32,000 divided by 3x cubed. And then you can sub in d2a dx squared and then dot dot dot. This one is minimum. Because x is positive, so d2a dx squared must also be positive. And when it's positive, means that it's a minimum point. You can sub in the value yourself to check. Okay? Okay. Question 5, a calculator must not be used here. Show that tangent 75 degrees is 2 plus root 3. Okay, this is quite famous actually. is a special angle also. In fact, you can derive it from tangent 30 degree plus 45 degree, which is, if I use the addition formula, tangent 30 degrees plus tangent 45 degrees. Divide by 1 minus tangent 30 degrees, tangent 45 degrees. But these are both special angles. We know that tangent 30 degrees is 1 over root 3, or root 3 over 3, and tangent 45 degrees is 1. So you get root 3 over 3 plus 1, 1 minus root 3 over 3. Multiply the top and bottom by 3, and use conjugate surds. Okay, so I'll get 3 minus root 3 down here. If I multiply by this by 3 plus root 3, and the top also. Okay, the bottom simplifies to 3 square minus root 3 square, so this is 6. And here at the top you get 9, 3, 12, so you get 12 plus 6 root 3. Yeah, and this is 2 plus root 3. Cool. Use result from part A to find secant square 75 in the form A plus B root 3. Okay. Secant square 75 degrees, remember, is always 1 plus tangent square. So you get 1 plus 2 plus root 3 square, which is 2 square plus 4 root 3 plus root 3 square, which is, well, it's going to be 4 plus 3, which is 7. So you get 8 plus 4 root 3. Okay. Hence express cosecant square 75 degrees in the form C plus D root 3, where C and D are fractions. Oh wow. I'm very surprised by this question. So many easy parts. This is just the reciprocal, which is the quarter of, how about I write it this way? Two plus root 3, multiply by the conjugate, 2 minus root 3. The bottom becomes just 1, so you get 4. So you will get half minus quarter root 3. Yeah, it's actually very simple. Solve the following exponential equation. 2 power x plus 4 power x minus 1 is 15. So we see 4 power x minus 1 is actually 2 power 2x minus 1, right? So let u be 2x, so we're going to use a substitution to solve it. And we know that 4 to the power of negative 1 is 2 to the power of negative 2. So what I can do is I can write u plus quarter u square equals to 15. Simplify this and get a standard quadratic equation. U square plus 4u minus 60 equals to 0. And if I think this can be factorized. U plus 10, u minus 6 equals to 0. So I get u equals to minus 10 or u equals to 6. So 2x equals to minus 10, which has no real solution. Or 2 power x equals to 6. So x is ln 60 divided by ln 2. And you can figure out what this is. It's 2.58. Trace F. The curve 5 minus e power 2x intersects the x-axis at A and the y-axis at B. Find the coordinates of A and B in logarithmic form where appropriate. So the x-axis at A, so that means y is 0. So e power 2x equals 5. So this simply implies that x is half ln 5. And leave it like that because it's a logarithmic form, right? So A is half ln 5, 0. What about the y-axis at b, well, that's quite simple also, right? Because all you need to do is submit x equals to 0, and you'll get 4. So b equals to 0, 4. What is the gradient of the curve at a? So for this part, you have y equals to 5 minus e power 2x dy dx. You bring down the 2, so you get negative 2e power 2x. The gradient of the curve at a means that x has to be equals to half ln 5. The 2 and a half cancel, so you're left with negative e 2 times e power ln 5, which is just negative 2 times 5, which is negative 10. Okay, so that is the gradient of the curve. Two countries are separated by a border that runs from west to east. A and B lie on this border. So a helicopter flies 30 km from A to C. BAC is theta degrees. The helicopter then travels 20 km to a village D angle of 90 degrees to AC. You can assume the helicopter always flies at the same height. The shortest distance from D, its border, is 30 sine theta minus 20 cosine theta. So this border is here. So how do you find this distance? Well, this is also a right angle. And so there's a bunch of trigo to do here. But basically this is also a right angle, right? And therefore this here is also theta. Okay? Let me make that clearer. This is a right angle. And therefore this is also theta. So 30 sine theta. So BF equals to 30 sine theta. And BD equals to, well, not BF, but rather the foot of perpendicular. So let's call it E. Okay? Let's call this, okay, so this here is, the ED is the distance we want, so no. Let's call this DF. DF is 20 cosine theta, right? Because adjacent, yeah. So you just take EF minus DF, and that will be the answer. Express this in the form r sine theta minus alpha. Okay, we're quite familiar with this already, I think. R will be the square root of 30 squared plus 20 squared. And this is, well, I can actually take out the 10. So I'll get 10 square root 3 squared plus 2 squared, which is root 13. Alpha is the inverse tangent of 20 over 30. Okay, and what's this? .690 degrees, 3 dp. Okay. Find the value of theta. Village D is 10 km from the border. So this is just solving 10 root 13 sine inverse, so or rather sine theta minus 33.690 degrees equals to 10. So theta is sine inverse 1 over root 13 plus 33.690 degrees. And you can figure out what this is. You'll get 49.8 degrees. Not sorry, 1 dp. Okay? Yeah. So that will be the value of theta if D is 10 km from the border. The equation of curve is this. Show that dy dx is 3x minus 2 divided by root 2x plus 1. Okay. a bit generous. Oh, I forgot to put a y here, so I guess I should put this. Okay. dy dx, so we use product rule, right? So x minus 3. If I differentiate the root 2x plus 1, I'll get a half here. And I'll bring the 2x. Okay, so what I'll get is basically half root 2x plus 1. Differentiate the 2, I'll get the 2 here. Okay, and then add root 2x plus 1, differentiate x plus 3, you just get 1. Okay, so you get x minus 3 divided by root 2x plus 1. And to make a common denominator, we multiply the top and bottom by root 2x plus 1, so I get 2x plus 1 divided by root 2x plus 1. And it's just a matter of combining fractions. You'll get 3x minus 2 root 2x plus 1. A particle moves along the curve in such a way that the x-coordinate is increasing at a constant rate of 0.15 units. Okay, find the rate of change of y-coordinate when x is 4. So I'm given the x dt is 0.15. So really, dy dt is just dy dx times dx dt, which is 3 over 20, 3x minus 2, root 2x plus 1, and then dy dt at x equals to 4 is 3 over 20 times, if I put in the 4 here, I will get 10 over 3, which is half. So 0.5 units per second. Use this result to evaluate the integral from x to 2x plus 1, root 2x plus 1 dx from 0 to 4. Okay. So integral x over root 2x plus 1 dx 0, 1. There's actually another way to, 4. There's actually another way to evaluate this integral, which is long division, but not sure if your tutors will teach you that. It's basically the GCE method of evaluating an integral like this, but we'll follow the method here. Notice that I have 3x minus 2. Wouldn't it be nice if I can get the 1/3 out? So what I'll do is I will actually integrate 0, 4, 3x minus 2. Let me just separate this border. Over root 2x plus 1. Then add back the 2. So this is how you do it. Okay? And then you'll notice that I actually know how to integrate the first one, which is just x minus 3 root 2x plus 1. So I'll get 1/3 x minus 3 root 2x plus 1. Now how do you integrate this? This is something you should know how to integrate, right? So this is the reverse chain. So your new power is half. So you get 1. Then you divide, so you get 2 divided by the derivative, which is 2, so you get 1. Divide by the new power, which is half, so you get 2 again. So you actually get 2 root 2x plus 1. And I can evaluate this from 0 to 4. Okay, so you'll get 1/3. Okay, if I put in 4 here, I'll get 1 times root 9, which is 3. So 3 plus 6 minus, okay, this is negative 3 and 3, so you get plus 9, and then minus, negative 3 and, yeah, it's just negative 3, so plus 3 minus 2, which is 10 over 3. Okay? Let me show you that there's actually another way to integrate this, which kind of uses long division. Basically what you do is x over root 2x plus 1 is x plus half minus half. root 2x plus 1, which is half root 2x plus 1 minus 1 over 2 root 2x plus 1. So this is the other way that you would do the integral, although I don't think your teacher may have covered this method, because this is a common technique for GCE. Okay? The equation of a circle is this. Find the radius and coordinates of the center. So for this one, as usual, complete the square. X minus 8 square plus y minus 1 square, right? Okay. We get 64, 65. And then we get plus 40 equals to 0. So if I have plus 65, it will be 25. So this will be 25. Okay? So therefore the radius is just the square root of 25, which is 5. The center equals to 8 and 1. Right? Find the shortest distance from the center from the circle from the line y equals to 2x. Explain why this circle does not intersect the line. Okay, well, we're going to find the line that has gradient half. So essentially what we're going to do is we're going to let L be the line perpendicular to y equals to 2x and through the point 8 and 1. So the gradient is the negative reciprocal, which is negative half. So the equation will be y minus 1 equals to negative half x minus 8. So y is negative half x plus 5. Equate this to y over 2x, and what you will get is x equals to 2 and y equals to 4. So shortest distance will be square root of, so consider difference in x, so you get 2 minus 8 square plus 4 minus 1 square. Okay, and here you get 6 square plus 3 square, which is 45, so you get 3 root 5. Okay, and root 5 is 2.23 something, so this is actually greater than 5. So this explains why the circle does not intersect the line y equals to 2x, because that distance is greater than the radius. So distance greater than radius. Of course, for those of you who know, you can also use cross product to get the shortest distance, but I think it's not in O-level syllabus. The point C11,5 lies in the circle, and the point D is such that CD is the diameter. Find the coordinates of D. So for this, CD is the diameter, the center is a midpoint. So let's call it M, which is the center of the circle. So what I want is, I want the vector CM, or how about I write it this way? I write dm, this must be the same as the vector mc, which I already know what this is, I can calculate it. It's just 3 and 4, right? Okay, so what is OD? It is OM plus MD. Oh sorry, no, OM, I'll find OM rather. No, correct, OD. equals to OM plus MD. Okay, and this is 8.1 plus 3.4 or minus 3.4 rather. So you'll get 5 and 1 minus 4 minus 3. Okay, so therefore D is 5 and negative 3. Okay, of course there's a variety of ways that you can get the answer. Okay, last question. The diagram has this curve 9 over 3 minus 2x. The tangent to the curve at minus 3, 1 is drawn. Okay, so we have the y-axis at A and the tangent intersects at B. Determine whether B is nearer to O or A. Okay, so for this we're going to need to find the coordinates of A, of course. So at the x-axis, or the y-axis rather, x is 0, so you get A equals to 0 and 3. And then now I have y equals to 9 over 3 minus 2x. What is dy dx? So I'll normally get a negative power, or rather it will become negative because of the power being negative 1. But there's a negative 2 here, so when I differentiate that, it's going to become positive again. So I'll get 18 over 3 minus 2x squared. Okay? dy dx at x is negative 3. So that is going to be 18 over 9 squared. Yeah. Which is 2 over 9. So the equation of tangent is y equals to 2 over 9 x plus 3 plus 1, which is 2 over 9x plus 5/3, and therefore b is 0 and 5/3. So 5/3 means that it is closer to A. So B is closer to A. Since 5/3 is greater than 3 over 2. Or rather, yeah. Basically, if it were less than 3 over 2, it would be closer to O instead, because OA is 3, right? The area of the shaded region is exactly A ln 3 plus B. Find the constants A and B. Okay, so to find this area, we're just going to take the area of the trapezium underneath as well. So area of trapezium, so let F be the fold perpendicular from P to the x-axis. And this is minus 3 and 0, right? And let's just indicate that this is 0 and 5 over 3. PFOB is a trapezium, half times the sum of parallel sides, which is 3 plus 5 over 3. Oh no, 1 plus 5 over 3. And the height, which is 3. Okay, so this is 4. Okay, and from here you can see that the area that we need is the area under the curve minus the trapezium. So the area equals to the integral negative 3 to 0 of the curve 9 over 2 minus, or rather 3 minus 2x dx, whatever this is, then subtract the 4 from the trapezium, which is, okay, so take out the 9. Now when I integrate, I need to divide by 2 and put the negative outside, so I'll get 9 over 2. Put it outside, we'll have the ln modulus of 3 minus 2x, and this is negative 3 to 0, then minus 4. So if I evaluate this, I'll get negative 9 over 2 ln 3 plus 9 over 2 ln 9 minus 4. Okay, but ln 9 is 2 ln 3, so we need to express it in terms of ln 3, right? So you'll get 9 over 2 ln 3 minus 4. So A is 9 over 2 and B is 4. Negative 4. Yeah, those are your values of A and B. And that is it for the A Math paper 2. So yeah, overall easier than paper 1. Hopefully this year's students found the paper okay overall. Hopefully you guys do well. And I hope that for the questions that you guys were not able to do, now you know how to do them. And I'll see you guys in 2023. I think this will be my last video this year, 29th of December. I'll see you guys next year. In January, I'll try to find time to do the H2 math papers. However, I am also getting ready to do some part-time jobs, so I will probably need a bit of time for that. But until then, I'll see you next time. Take care.